lesson 5 is just some more speaking on equivalent fractions. And the first little 2 sentences here on this page are really important, okay? Because we've been saying this word for a while now, and I don't think any of us really understood it. I'm going to read it. Can you follow along with me? Simplifying a fraction means finding an equivalent fraction with a lesser numerator and denominator. Simplifying a fraction results in an equivalent fraction with fewer but greater unit fractions. That sounds, I'm sure, on a Monday morning like, wah, 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 wah. Yeah? Okay. Basically what it's saying is if you see how there's 12ths here? You see all these 12ths? Is that simple? If I have 4 12ths, is that simple? Or is there a lot of parts there? There's a lot of pieces. Can we find something that's a little simpler? That's a bigger piece, unit piece, than this is a little unit piece. 1/12 is a little unit piece. I want to know if 4 12ths is equivalent to something the same size, only 1 piece or maybe 2 pieces. So how are we going to do that? Let's look at these 2 questions here. Maria had 12 boxes of apricots. She sold 10 of the boxes. Write the fraction of the boxes sold and lightly shade the 12th fraction bar to show this fraction. So your picture should look something like this, right? Now what it wants us to do is to group the 12ths that we just colored, to group them. So we're going to put them in smaller groups. Okay? With an equivalent fraction with a lesser denominator. Show the new fraction by dividing, labeling, and lightly shading the blank fraction bar. Okay, I'm hearing a couple different things. You could divide it by 6, because you know that 12 divided by 6 is 2s. So you can make groups of 2, and you would have an even amount, right? Okay, but now what am I going to move this fraction bar into? Oh, good job, friends. So this is 1/6, this is 1/6, this is 1/6, this is 1/6, and this is 1/6. So what would be our equivalent fraction to 10/12ths in sixths? Taylor? 5/6. And all we did was group the 12ths into bigger pieces. So 2 12ths fit into 1/6. Well, mine wasn't. I don't know what happened there. In problem number 2, you formed groups of 12ths to get a greater unit fraction, because 1/6 is a unit fraction. Thumbs up if you agree. Okay. 1/6 is greater than 1/12. Thumbs up if you agree. Yes. This piece of fraction is bigger than this piece of fraction. Okay? How many 12ths are in each group? 2. Good job. 2. In other words, what is the group size? Well, there's 2 12ths in each group, right? This is the group right here. This 1/6 is the group, and there's 2 of these in that group. That's all I'm saying. So what did I do? How did we figure that out? We divided by what? You told me this already. How many were in the group size? We did it by 2s. 10 divided by 2 is 5. 12 divided by 2 is
6.
Again, 10/12ths is equal to 5/6. Whatever you do to the numerator, you do to the denominator. What I want you to see is that you're going from a small unit fraction, 1/12 is teeny tiny, it's a little piece, to a bigger unit fraction. 1/6 is bigger, that's 1/6. Okay, this is 1/12. Smaller to bigger. You're grouping the smaller ones into bigger pieces. Okay, that's the most important thing. Now, what we were doing last week on Friday, we were doing the opposite. We were going from the big one to the smaller one. We were doing the opposite of this on Friday. So we were multiplying, because when we want mini, we multiply. Now I want those little pieces to be a bigger piece, so we're dividing them into groups. Okay? So down here, use what you know to find these equivalent fractions. You may want to sketch a thirds fraction bar below the 2 fraction bars above. Well, I just want you to tell me, how do you think I got from 12 to 6? I didn't multiply because the small number got smaller. So what did I do? Yell it out. Divide. I divide by what? 2. Whatever I do to the bottom, I need to do to the top. So 8 divided by 2 is? 4. How do you think I got from 6 to 3? Because the number's going from a 6 to a 3. That's getting smaller. So I divided by 2. Whatever I do to the bottom, I need to do to the top. Divide by 2. So 8/12 equals 4/6, which equals 2/3. If you use your tiles, your fraction tiles, you will see that these are all take up exactly the same amount of space. It just depends on how many pieces there are. Which is the most simple? You've got 8 pieces here, you've got 4 pieces here, and you've got 2 pieces here. So which do you think is the simplest? 2. Same thing here now. We're going from 12 to 6. What did I do? Get bigger or smaller? Smaller. So I'm going to divide by 2. Divide by 2. Whatever I do to the bottom, I'm going to do to the top. 4 divided by 2 is 2. 2 divided by 2 is 1. So 4/12 equals 2/6 equals 1/3. What is the simplest thing there? 4 pieces or 1? 1. 1 piece is simpler than 4/12. So what you're seeing on number 7 is that there are some improper fractions. But that's okay. You can still divide by 2 and get this. You can still divide by 2 and get this. Simplifying means you're making it in the simplest form possible. That includes being improper. We can't divide 5 by 2, can we? Well, you could, but you'd be making fractions out of fractions. Does that make sense? Yes. So you've divided it out enough. Now you need to make it a mixed number, and the mixed number would be your simplest form. Okay? Let's go. This is one tactic. Turn the page, and we're going to see another tool we could use, and I think it's the number line. And where is the simplest form here? Is it at the bottom or is it at the top? The bottom. Notice that from here to here, every single one of these pieces is the same. Which one has the least amount of fractions, the least amount of pieces? The bottom. So it is the simplest form. So what I want you to see here is like on 6/18. Can you just draw a box around 6/18? So 1, 2, 3, 4, 5, 6/18. There's a lot of little pieces there, friends. So if I want to simplify it, what would it be in 15ths? 5/15. What would it be in 12ths? 4/12. What would it be in 9ths? 3/9. What would it be in 6ths? What would it be in 3rds? Okay, so what did I do to go from here to the simplest form? To go from the smallest unit fraction to the biggest unit fraction, what did I have to do? Turn to your neighbor and talk about it. Write the group size for each fraction in the chain of equivalent fractions. So the 18ths were, what did we say, 6? How many 15ths were there? 5. How many 12ths were there? 4. How many 9ths were there? 3. How many 6ths were there? 2. How many 3rds were there? 1. So hopefully you're starting to see kind of a pattern, yeah? So we did 6 parts. We have 6 parts up here. 1, 2, 3, 4, 5, 6. If we were to divide 18 by 6, 18 by 6, whatever we do to the bottom, we do to the top, we're going to get 1/3. The simplest form. 5 divided by 5, 15 divided by 5 is going to give us 1/3. We want the simplest form. I hope you're writing this as I'm writing this. We are dividing by the number of pieces. So 4 divided by 4 is 1. 12 divided by 4 is 3 divided by 3 is 1. 9 divided by 3 is 3. 2 divided by 2 is 6 divided by 2 is 3. So are you kind of starting to see the pattern there a little bit? That's a 3. I just didn't write it well. No, I'm not going to write that. You don't have to do every single piece all the time. We've used our number tiles to visually see the equivalents. Did you see on the last page how 6/18 is exactly the same size as 1/3? Yes. Now another tool you can use is our multiplication table. Okay, and I remember that trick that we used on Friday was kind of cool. I didn't even know this trick. So I thought it was pretty revelational that if you took a multiplication chart, you circled your fraction and moved right along the multiplication table, you have your equivalent fractions. That was kind of a oh moment for me. Like a whoa, that really works. So today, when we move from right to left, how does the size of the unit fraction change? When you're going from, we have circled here 1/3, okay, and we're going 1 to 10 and 3 to 30, how is our unit fraction changing? So I heard some of you say this. If you're moving from right, so to left on your multiplication chart, the fractions are still equivalent, right? 10/30ths is still equivalent to 9/27ths and 8/24ths and so on. Thumbs up if you understand that much. They're all still equivalent. However, the numerator, that's this top number, and the denominator are decreasing. Are they getting smaller? And in fraction world, what does that mean? Well, that means that the unit fraction, our tile size, is getting bigger. And our units, how many of them we have, is getting smaller. Remember, fraction world, our numbers are kind of backwards. In fraction world, the smaller the number, the bigger the piece of pizza. So, the unit fraction, think units like 1/10, 1/9, 1/8. Those are getting smaller. The bigger pieces, the pieces are getting bigger because 1/8 is bigger than 1/10. Do you know that much? If you have a pizza with 10 slices or a pizza with 8 slices, which pizza do you want the slice from? Which one has the bigger piece? The 10ths or the 8ths? 8ths. So the unit fraction is increasing and the number of them are decreasing. So you're not going to have, like in our other example over here, there's 6 units here, 5 units here, 4 units here, 3 units. The units, how many pieces, is decreasing. The size of the pizza is getting bigger, but it's still the same size. Like the overall, the pizza is the same. It's just this one has 1 piece, this one has 2 pieces, this one has 3. Get it? So the difference in this one is the fractions are still equivalent. The numerator and the denominators are getting bigger. They increase. The unit fractions, the 1/3, the 1 1/6, the 1/9, the 1/12. Those are getting, pieces are getting smaller. They decrease. And the number of them, so in order for me to still have 1/3, I need to have 5 smaller pieces, 5/12. If I want to still have 1/3 of the pizza, I need to have, if I'm splitting it into 12ths, I need 5 of those 12ths to equal 1/3. So if table 1 had a pizza, table 2 had a pizza, and table 3 had a pizza, and I said, you can have 1/3 of the pizza, but your pizza, table 3, yours is in thirds, yours is in 12ths, table 2, and yours is in 15ths. Table 3 would have 1 slice of pizza. Table 2, you would have to eat 5 pieces of pizza to equal that 1/3. And how many would you have to eat over here for 15ths? 3 pieces. No. 15ths? 5. 12ths is 4. Sorry. 12ths you would be eating 4 pieces, and 15ths would be eating 5 pieces to equal 1/3.